Today we're looking at how to configure I2C in your STM32 board. A lot of issues that I've had when trying to learn this kind of embedded development was that I started off with Arduino and I didn't really know how to break into this side of things because Arduino makes it so simple and useful. So here I'm going to show you a quick way to configure your STM32 and to get I2C running. So here I have a piece of code here, and what we're doing is we're using this SI7021 temperature sensor. So what this is, it's just a very basic temperature sensor. I'm going to show you how to get these numbers, values, and whatnot. But before I show you and explain this, I'd like to say there's an even easier way, and that is using someone else's library. There is no shame in using someone else's library. It is open source if it is, and many other engineers, we all tend to use someone else's library, or we reuse the same pieces of code over and over again. So why bother if you can just use it? So how do we find these types of libraries? Well, I'm in this GitHub page here, and I've literally just searched SI7021 STM32 libraries, and I've been presented with this page where there's a whole port of useful things that I could use. So this person has kindly put all this up, and they even have sensors for this one, which is a very popular temperature humidity sensor, and here's our temperature humidity sensor here. So ideally what you would do is simply download these files, import it into the respective source and header files, and you can use the commands and you're ready to go. For example, here, and so on. But let's go through it. So I've used this code here. So this is the header file from here that I've used his library. I'm going to show you what it actually does. To start off I2C communication, you need an address. To get this address, you have to read through the datasheet of your chosen device. So here we are, the datasheet of this SI7021. We see it is precision relative humidity plus minus 3%, plus 0, minus 0.4%. Of course, this depends how you configure it. And we're just going to scroll all the way down here. We're trying to find something. I2C interface, and here you see the 7-bit slave address is 0x40. So this is the address that we need to use. Sometimes it's really easy to find these addresses, sometimes it's really difficult and you need to do a whole lot more reading, but this is the type of thing you're looking for. What is the slave address of this device? And the reason for that is I2C, it's a multiple bus interface type of thing. I highly suggest you read up more about it before you try these out, because it always helps to understand what you're trying to code. But essentially you can have multiple devices on this same bus. So I could have 5, 6, 7 devices on this, and in order to communicate with them, we need address. We need to tell our STM32 what we want to talk to, what we were listening to. This is our slave address. Our STM32 is the master, and we want to communicate to this address, which corresponds with the temperature sensor. So now that we know that, you may be wondering, okay, but those commands, how did he get this? It's all in the datasheet. Everything will be told to you in the datasheet. So you even have these flowcharts on what you expect for the command during it, and you can check this out when you're debugging or on some logic analyzer, whatever you want. Measuring temperature also, we get write, acknowledge, so on, read, acknowledge. This is the formula that's used to get the temperature out of it. So you're not left by yourself. It's not an impossible task, but do some more reading and you soon find out that, oh, I'm getting the hang of it. But do take your time with it. It may seem frustrating at first, but stick out with it. So we come to here, we see our address. I've labeled it here. This is our address. And for our script, we need to left shift the bit by 1. So you do that, so left shift by 1 and or 0x01 to change it as so, and this gets our new address. Then this is only when you have to read something. To write something, we can just use this address. Since we need it in 7-bit form, we have to shift everything. So now we're going over to what are these extra commands. The thing is with you, when you deal with sensors, there are multiple registers, there are multiple things this sensor could do, and each function, if you will, has a corresponding address. You need to address this address. You need to tell it, where am I reading to? What command am I giving it to? So this is why we have this function here. Measure temp to hold node master. So this is just a separate function of whatever, a separate mode of it. We want to gather the temperature and humidity. Back in our datasheet, we are looking at the I2C command table. Of course, this comes in all different types of flavors and sizes and shapes. And we see that measure relative humidity, hold master mode, okay, measure relative no hold master mode, this is the one we want, 0xF5. Keep that in mind, write that down, put it in your code. We also want to measure temperature, okay, that's 0xF3. We have a write heater control, read heater control, we have all these different things that we can do. Back in our code, we have listed it down, we have defined it, now we can refer to it much more simpler. I highly suggest you do these types of things, this is good practice to do so, but as I said, I'm just showing you an example. We come down to here, we have inputted all the libraries that we need, and this is just the bare STM32 HAL generation. Of course, everyone else, maybe your colleagues, your friends will look different compared to this, but this is what you should get when you just freshly generated a HAL type thing using the STM32 Cube IDE. So before we even get to our main, we are writing down all our functions here. Usually you do this in a different C file or header file, whatever. You would try to make the main source code as short as possible, use as many functions as possible. So we call this SI702 measure humidity. We're referring it to the handle def, and as you see, I've commented things what's actually doing. So this is base for data, what we need to store it in. Setting address store data temporarily. So we start to measure this, and we do this. We use the HAL I2C master transmit. Now, the brilliant thing about the HAL layer, or whatever this is called, is that all these functions and things, they're all done for you. You don't need to think about them. You don't need to flick registers on and off. It's easy to get something up and going, to test something with this HAL. Now, because of this, all the I2C things are sorted for us, and we just need to fill in the blanks. So if I do a fresh one, if you press Control Space, HAL underscore I2C underscore master underscore transmit, and there we go. You can see we just need to fill out these separate things here. You can easily Google this and you can find out what you need to put in. So I'm not going to tell you all here. Essentially, we are just filled it out. The reason we've put this is because you will get a HAL OK if everything passes. After that, we give it a little bit of a delay. Then after we've transmit, we always have to receive. So now we've asked it to say we want this type of data, we have to receive it, we want to know what it is. So we do that. Same thing again. If we read this, we can get all the different values and we know what we're looking for. Again, we want to get a HAL OK. If it's not a HAL OK, then this thing would fail. And that's all it is. It's the same thing for the measure humidity, measure for temperature. So I've done the exact same thing. I've listed all this down and I've imported the code. Of course, it's from the library, but I've just shown you in the datasheet that this formula here corresponds to the datasheet, and that's what we're doing. This is just an error code that's been implemented, and we've returned this value into our temp. Now we do this because we want to spit this out. It's no good if we have data if we cannot read it. So you have to initialize everything when you usually come down to here. And then we go into our reading. So we have view int32 humidity, which is our saved value. Afterwards, we have our measure humidity function. Okay, our function that we've just shown. And we have the temp function, what I've just said. So we save our value in respects to the function we've just shown. We convert this temp C, and now we just print it out. So let's give it a go. So I am going to upload this. We've got 2 warnings. There'll be something here. I'm not too bothered about them. It's doing its thing, and there we go. So I've had this putty in the background, but I'll reopen it. I select my settings here, open, and there we go. So we have our values spitting out at us. Of course, you could change this depending on what you want to write and depending on the significant figure. I don't even have it to, I think I need to make changes here, but you get the general idea of it. So I'm going to put my finger on the sensor and we can see the temperature rise, the relative humidity rise. I take my finger off, and it still rise, but should go down a bit. Yep, there we go. And that's all that there is to it. So this was a relatively short one. I do highly recommend you read a bit more as I'm not doing it enough justice. But this was a brief intro on how do you get these things up and running. What I highly suggest is that you read through I2C, how does it work, what it does, have a bit more knowledge on it. And then if you're using STM32, I'd say suggest playing around the HAL. Use libraries when you can, save yourself time. It really, really, really isn't a bad thing to use other libraries if you know they're good. You can even tweak them to your own liking, to your own wordings, as long they've done the majority of the work. And afterwards, I would suggest reading up on all the functions like the HAL underscore I2C master transmit, S/F, and things like this, and HAL UART transmit. That's all it is. Take your time with it, and I hope it goes well.